Hello, this is Alex. I will be doing the Kinetic sand assignment, the last assignment of the semester. Sorry, my dogs are right here. So basically what we're going to be doing is we're going to be making this sand. We're going to be using regular sand here. We have in a pack. We're going to be mixing it with starch, water, a little dish soap, and some baby oil. So we first have the sand, which is sort of the base, and then we are going to mix it with cornstarch and water. Cornstarch is a polymer. It is a polymer of glucose. It's just basically what a polymer is just any class of natural or synthetic substance composed of large molecules that are made from monomers, which are the smaller subunits of that. So we have that. We're going to mix this and water together, which is going to make it a thicker substance, and also add a little soap and baby oil, which is going to make it a little thicker. We're going to add it with the sand, and then what it will do is going to create this polymer substance, non-Newtonian-like fluid where the viscosity is unorthodox, typical to Newtonian fluid. The Newtonian fluid, I'm going to go a quote here, where a Newtonian fluid is a fluid that remains consistently, the viscosity remains consistent under different pressures. A non-Newtonian fluid is a viscosity that can change when subject to pressure or force. So the non-Newtonian fluid is going to be unorthodox in that when you apply pressure, the viscosity will increase, but when you have low amounts of pressure, or let's say you have gravity, which can be slow and slowly degrading to it, it will actually become more of a liquid. So let's attempt this. As you can see, I've already attempted it before, made a huge mess, so we'll see how this goes. All right, let's start. Get the sand here, a giant thing of sand. Actually, I think the best thing to do would actually be do this first. So we're gonna get some cornstarch. Gonna do a few tablespoons here. Gonna do a few here. One more. And this is going to be basically the basis of the polymer here. Well, it is a polymer, but of the substance that's a non-Newtonian fluid. Let's put a little bit more. Okay. It's everywhere if you're wearing dark colors. Okay, we're gonna pour a little water in here. Mix it up. You can hardly tell, but it's sort of gooey now. Get a little closer. It's more, it's water. I'm trying to mix it up. It's sort of sticking to the bottom of the bowl. It almost looks like gum, like a watery gum. So, got that mixed up. I'm gonna add a little dish soap. Love these new containers by Dawn. It's not a commercial. I am not being funded by Dawn. Pure, this is no advertisement. Relation. No contracts were signed. Okay, so that's mixed. Now we're gonna add the sand here. And then after I get done doing this and mix it up, we'll go over this. Okay. Add a few parts sand. Mix it up and we'll reassess. So we want to make this the right texture slash viscosity, so I'm gonna add sand, more sand and more sand to it. Let me just add way more sand. Okay, we're getting there. So, okay, so right now it's still sort of mushy, just a mush sand. Okay, I'm just gonna mix it together some more, see if we can. So what we're doing is we're mixing this together, trying to create the polymer to bind with the sand, and it's gonna be this suspended, the sand's gonna be in a suspended non-Newtonian fluid, so where we can sort of manipulate it ourselves. And with this, in theory, if I can get this to work correctly, it's not going great right now. Looks sort of like mush, sort of like my last attempt. I'm getting nothing but mush. Okay, I think I've failed, and I've just made another huge mess. Okay, I will go over my conclusion, sorry. Okay, so I've tried to create this kinetic sand. You have the polymer, so what should have happened, I should have just created sand. It looks like regular sand, but this sand would be hydrophobic, meaning not loving of water. One of the reasons kinetic sand was actually made was to help clean up oil spills, because it is hydrophobic, and it would, when you put this in the water with the oil spill, it would run away or fall away from the water, and it would absorb the oil. So with this, what it should have done, if when we were talking about pressure, non-Newtonian fluids, if I would have had it into a ball here, a perfect ball, if I would have smashed it, the viscosity of it would have actually increased, and it would have become very thick with all the pressure. And the theory behind that is you're applying pressure at a very fast pace, you're applying force, and the atoms, the molecules, are unable to disperse in a quickly manner, so it is harder to for them to move. So the viscosity is going to increase. It's going to be like a wall. But let's say I have it in my hand, for example, like this, it would fall through like water, or like a slow moving current of sand, because if you have that gravity, that force pushing down on it slow, there's time for it to disperse, and it's going to fall very, very slowly, just like this. But when you have a lot of momentum coming in at one time, the molecules do not have enough time to disperse, and you're going to be hitting a board. So my science projects, like the last few, have failed miserably. After many attempts, I could not get the right ratio. There's a perfect ratio. I've tried just sort of playing with it different ways. I tried the correct way, like the way the video said, but my lab did not work. But so my name is Alex Ivy. This is lab number 8. Thank you.